In this video, let's use FF3 to simulate a double-studded wall as shown here. Here is the horizontal section cut of the wall in Rhino. I skipped the drawing process, assuming you can draw it yourself, following the dimensions on the sectional perspective. The system unit is set to inches to be consistent with the sectional perspective drawing. I used only rectangles. You can use surfaces or closed polylines, but the geometries must be planar. Make sure that your drawing is accurately snapped to the geometries without voids or overlapping regions. Later I'll demonstrate what they are. I put the rectangles in separate layers. It is not required, but it helps you to organize the drawing. Here is the cladding layer, furring, air gaps, OSB sheeting, 2x4 studs, gypsum board, and the insulation filling the stud cavity. If you look at the image, depending on where you cut the horizontal section, the cladding layer will be different. You can use a vertical section of the cladding layer, which does not affect the simulation results. It will look like this. And the exterior boundary would look like this. For this example, we will simplify it to a straight line. Let's open Grasshopper and open the wood stud example. Save it as a new document. Delete the code block for the metal stud wall. Let's start setting the geometries. Select the gypsum rectangle and set it to the gypsum battery. Select the insulation rectangles and set them to the insulation battery. Select the wood studs and the furring strips and set them to wood studs battery. Select the air gap rectangle and set it to the air gap battery. Select the OSB rectangles and set them to the plywood battery. You can include the cladding to the plywood battery, but you can also use a separate battery. Use a geometry battery to reference the cladding rectangle. Change the name to cladding. Hold the Shift key to add the cladding battery to the shape battery. Since we don't have the brick layer, we can delete this set of batteries. If we have another layer with a material that is not shown here, you can copy one of the layers. Set the geometry to the battery and change the name accordingly. Then go to the Honeybee Energy tab. Under the Constructions panel, select HB Search Materials. Use a panel to search for the keyword for the material, for example, concrete. You may get a list of materials. You can ignore the thickness and only look at the type of concrete. You can use the List Item battery to select the one you want. You can further dissect the material to see if it is what you intended. Under Constructions panel, use Deconstruct Material battery. You can verify the properties of the material. The name is 12-inch normal weight concrete floor. Thickness is at 0.3 meter. Conductivity is 2.3 watt per meter K. Density, specific heat capacity, and so on. If this is the material you intend to use, right-click on the panel, select Copy Data Only, and paste it to the panel that is connected to the material input. Make sure that there is no additional empty line at the cursor. If there is an empty line, use the backspace key to remove it. Once the layer is set up, you can hold the Shift key to add the layer to the model. If the material you intend to use is not in the library, you can use the HB Opaque Material battery to construct custom material by feeding all of the necessary input parameters. The last step is to set up the boundaries. Search for Line battery and make a copy of the battery. set one of them to the exterior boundary, set the other to the interior boundary. Replace the existing batteries. We've finished the model setup. We can run the simulation by setting the toggle to true. This model successfully ran, and the Rhino viewport shows the color-coded results. One common error during modeling is void or overlapping region. To demonstrate this, select the geometries in this rectangular area and set them to the WSDOS battery. Now you can see that the simulation battery has an error. Click on the bubble. The error message reads, "The geometry contains overlapping regions." This is because the rectangles in between the studs and furring strips are already set to insulation and air gap, and now they are double set as wood material. As the opposite example, if you forget to set material to one or more of the geometries, the model would not run because it thinks there is a void in the geometry. The void is not vacuum or air kind of void, but rather the computer does not know what to do kind of a void.